Hello, it's time for lesson 8.7. Here's your objective. I will be able to solve one-step inequalities. Let's see what we're talking about. Okay, just like last chapter, chapter 7, when we solved for the variable in an equation. So this is kind of like an equality. This is an inequality because it's not necessarily equal. Last chapter, to solve for a, we would have to get a by itself. So we would have added 5, cancels out, added 5, and a would equal 20. We check our work. 20 minus 5 equals 15. Great. Same kind of concept here with inequalities. So we have a plus 7 is greater than or equal to 10. All right, so same thing. We want to get a by itself. So I minus the 7, cancels out, minus the 7, and I'm left with a not equals to, a is greater than or equal to 3. Okay? So a is greater than or equal to 3. See, the only difference here is with an equal equation, I have an equal sign. With an inequality, my a is not necessarily defined. A could be a lot of things. A could be 3, a could be 4, 5, 6, 7, 8, 9, 10. A could be any number from 3 to infinity. But it can't be less than 3, but it says greater than. Over here, we have a definite answer. A has to be 20. Over here, a does not have to be a certain number. It has to follow the rule. It could be anything equal to 3 or greater than 3. All right? Stay with me here. If it's unclear, it should be clear pretty soon. All right, so I'm going to solve for x in this inequality, and then I'm going to graph it. Okay, so I've got to get x by itself. I'm going to add 3 to both sides. Cancels out. I'm left with x is less than 9 plus 3 equals 12. X is less than 12. Solves my inequality. Now I have to graph it. Okay? Now I might have made a mistake in the last lesson. I probably did with graphing these, but let's see something. If x is less than 12, here's 12 on my number line. I have an open circle there. Okay? If it's less than 12, it's going to graph like this. Fill out this whole line right here and draw an arrow because it goes on forever. I think the mistake I made in the last lesson is I did not tell you to put an open circle there if it's just less than. Now, if this was less than or equal to, I'm going to change the whole problem, then I fill this circle in. Okay, that means it could be equal to it or less than it. But since I'm going to go back to the original problem I had, it's not less than or equal to, it's just less than. So this should be an open circle like that, and that's how I would graph this equation, or this inequality, sorry. So take a quick look at that. We're going to do a couple examples. All right, over here I have, oh perfect, I have an inequality. I'm not sure why the 5 is underlined there. Let me fix that real quick. I don't like looking at that. This should not be underlined. Okay. I have n plus 2 is less than or equal to 5. Let's get n by itself. Minus 2, goodbye. Minus 2, and you get 3. So I'm left with n, I'll rewrite it up here, n is less than or equal to 3. Everybody say hello to Mrs. Martin. She's coming on down as I teach. She's going to pop over and say hi in the video. She's wearing a lovely blouse and pants right now. Say hi to the people, Mrs. Martin. Get in there. There she is.
I'm here.
And then she's
Are
gone.
you doing it right, Mr. Murphy?
I hope I am.
Okay, let's see.
So now n is less than or equal to 3. So I find my 3. Now I'm going to start with just a circle. But since it is also equal to 3, I'm going to fill this in.
This is one of my favorite lessons, Mr. Murphy.
It's so exciting.
It's so fun.
And it's got to. That's because Mrs. Martin likes to color inside the lines.
Yeah.
N is less than or equal to 3, so when I fill in my graph over here, it's just going to go that way. And I have to put an arrow at the end because it goes on forever into -1, -2, to negative infinity. Anything else, Mrs. Martin?
No, I came for chocolate.
Oh, sure. Grab a kiss.
Thanks, Mr. Murphy.
No problem. We also can do this with multiplication. So right now, I have 5x is less than or equal to 45. So once again, I have to get x. Are you looking for the chocolate still?
Yeah.
Right inside of the Hershey Kiss container, right in the middle of the desk.
Oh,
There you
that's
go.
old-fashioned.
Oh, yeah.
Must be old.
So I have to get x by itself again. So if this is 5 times x, I have to divide by 5. Boom, see you later. Divide by 5. I'm left with x is less than or equal to, and what's 45 divided by 5, Mrs. Martin? I can't remember that.
9.
9 is correct. There we go. She still got it. So x is less than or equal to 9. Oh, I didn't fill in my number line below because you have to make your own sometimes. So if I'm using the number 9, and when I make my number line this time, I should probably use numbers that go a little bit before 9 and a little bit after. So I'll put 9 right here, and I could probably make 10, 11, 12, 13, 14. On this side, 8, 7, 6, 5, 4. Notice that there's arrows because I don't have to start at 1. I know it goes forever, lower and higher. The number lines never end either way. Okay, so x is less than or equal to 9. So I find my 9. I start with a circle on it. But since it's equal to 9, I'm going to fill that circle in. And it's got to be equal to or less than 9. So here we go. I've just graphed it, and I put my arrow at the end. And there it is. That's how I graph it. That's how I solve for it. I'll erase all this. I think we have one more example to do. I think it's going to be division this time. And here we go. We have x divided by 8, or x over 8, or x eighths, is greater than 3. All right, I have to get x by itself. If I'm dividing by 8, I should multiply by 8. I do the opposite, all right? So I multiply this by 8, which is really 8 over 1. I multiply this side by 8, which is really 8 over 1, whatever. So my 8's cancel out, and I'm left with just x over 1, which is just x. And 3 times 8 equals 24. So I'm left with x is greater than 24. Okay, so now I have a blank number line again. I have to I'm going to throw 24 somewhere in the middle. I'll put 24 right here. And you know what? Just for fun, I can count by 2s if I want to. This could be 26, 28, 30, 32, 34. Counting down by 2s, 22, 20, 18, 16, 14. When you go by other numbers besides counting by 1s, you get a wider range to look at. You didn't have to do that. I could have done 24, 25, 26, 27, and so on and so forth. All right, so x is going to be greater than 24. So I'm going to put a circle on my 24, all right? But now I'm not going to fill it in because it's not equal to 24. It has to be bigger than 24. So I draw my line, my arrow, and I am all graphed out there. All right, so once again, I apologize from the lesson before. Maybe I'll have to refilm that for next year. And if this is next year right now, I didn't do it. So, yes, make sure if it's just greater than or less than, you leave an open circle. If it's greater than or less than and equal to, so if it's one of these or one of those, that's when you fill it in. But if it's just a greater than or a less than, you leave it open. All right? Good listening skills, everyone. Very proud of you. All right, now it's your turn. You have 2 problems here. Here's your direction for each problem. Solve each inequality and then graph it. All right, so number 1 and 2, you're going to have to draw your own number lines out there. So you have to solve, well, not solve for h. You have to find what h could be greater than or equal to. All right, so you'll get rid of the 6, and you'll be left with h is greater than or less than some certain number, and then you're going to have to draw your own number line. If you don't see it on here, I know what you did. I need to see you draw a number line and pick the numbers you want to put in there, but it should be somewhere near where h is. And then same thing for 5y is greater than 30. Get y by itself and then graph it. You could do it. I will see you soon.